Hello. Hello. So in this session, we are going to focus on generalized linked list. So what is generalized linked list? So suppose we have a linear list. Say A is equal to A1, A2, A3 up to AN. That means list A contains n number of elements, AN, A2 up to AN. Right? Generally, in linear list, all these elements from A1 to AN, they have the unique structural property and a single position. Unique structural property means what? Suppose I create a list of, say, fruits. So it will contain all the fruits. Suppose if I create a list of dates, so it will contain all the dates. A list of integer, all integers. A list of float values, all float. And likewise, means they have the unique property, structural property. But there are many applications where we need that every element of a list can have a different property. Then in that case, GLLs are used, or generalized linked lists are used. So by definition, a GLL A is a finite set of n elements where it may be either a node or an atom. Okay, so the same definition is over here. A generalized list A is a finite sequence of n elements where n is greater than 0, right? From A1 to AN, where the AI either are atoms or the lists. Means what? In your list there are n number of atoms, and every individual atom, every individual element can be a atom or it can be a list in turn. List of list can be the generalized linked list. So the element AI which are not atoms are said to be the sublists of A. Okay. So see, your generalized linked list is a set of element where every element can be a single atom or it can be a sublist of A. The list A itself is written as A of from A1 to AN. A is the name of the list and A1 to AN are the elements and N is its length. List names are represented by capital letters. So always keep in mind list name, say in this case capital A. So it is represented by capital letter. Atoms are lowercase letters. Okay. So here A1, A2, A3. So A1, suppose it is an atom, then you have to represent with a lowercase. Suppose second element A2 is a list, then you have to represent it with a capital letter. Okay. So the definition is recursive because within our description of what is list is, we use the notation of a list. Okay, so it is a compact way of describing a potentially large and varied structure. So list is a generalized linked list is a compact way of describing list of lists. Okay, so it can contain list up to the nth depth recursively. So some examples of generalized linked list are, say first one is D is equal to empty. So it is a null or empty list. Its length is 0. See, D is capital, so it is a example of generalized list. Now say capital A is equal to A comma BC. Here this is a list. A is a list of two elements. The first element is A and the second element is sublist containing B and C. Okay. Now check out third example. B is equal to A comma null. Now B is a list, generalized linked list containing three elements. First two elements are sublists A and the third element is empty list or null list. Now C, last example, C is equal to A comma C. So this is a recursive list of length 2. There are two elements. But now see, C list is itself a part of list. Okay. So C corresponds to the infinite list. So if we replace this C with AC, it will be like look like this. C is equal to A comma, C will be replaced by A comma, then A comma, and it will become an infinite list. Okay. Now example 1 is an empty list and it is seen to agree with the definition. So we can have the empty list also. Now, what is the node structure to represent this GLL? So we have this node structure: flag, data, down pointer, and next pointer. Okay. When flag is equal to 1, it implies that the down pointer exists. Means there is a sublist, okay, available. When flag is equal to 0, it implies that next pointer exists. Means no sublist, only the atoms. Then data means the atom, the value. Down pointer is the address of the node which is down of the current one, and next pointer is the address of the node which is attached to as the next one. So why generalized linked list? So see, we have seen various applications of normal linked list. Okay. Now, when the case comes of polynomial operation using the linked list, we can do and we can perform various operations on polynomials also. But if there is a multivariable polynomial, then the normal linked list, single or double, they might not perform very efficiently. So in that case, we have to use generalized linked list, and that is the main reason why generalized linked lists are used. They represent multivariable polynomials very efficiently. Okay. Now, how to write down a class for that? So we have to write down, say, class node. We have integer data to store our data. Then we have the flag, and then we have the two pointers, next pointer and down pointer. This is an example of GLL. So suppose list A is equal to A comma BC comma D. So how many elements are there? There are 3 elements. A, first element, second element is a sublist containing BC, and third element is D. Now how to represent it? So let's check it out. The first element is A. Flag is 0. Flag 0 means there is no down pointer, only next pointer. And second represents the data. So flag is 0. Second is A, that is data, and next is only next pointer. Down pointer is not available. Now check out the second node. Flag is 1, means down pointer is available. Okay, so next is a down pointer, and down pointer available means what? There is a sublist. Okay, which is that sublist? It contains 2 elements, B and C. Now for B, flag is 0, means there is no further down pointer. Okay, and next pointer goes to C. So for C also flag is 0, means there is no down pointer, and it is the last element. So next pointer is null. Okay, now for the second term only, down pointer, it goes to the second element, and the next pointer is also available to connect to the next element in the list. So for next element, it is again a single element. So flag is 0, data is D, and it is the last element. So next pointer is null. Okay. So this is how the lists are represented. GLLs are represented. Now very important is how polynomials are represented with the help of GLL. So typical node structure for polynomial is flag, variable, exponent, and next pointer. Now flag value is very important. If your flag is 0, it means that variable is present, like x, y, z, w, v, m, n. So your variable is present in the polynomial. Then flag is equal to 1 means down pointer is present. Okay, and flag is equal to 2 here means coefficient and exponent is present for the variable. Okay, I repeat again, flag is equal to 0 means variable is present, x, y, z, m, n, v, like this. Flag is equal to 1 means down pointer is present. Down pointer is present means what? That particular term has multiple variables, more than one variables. Okay, and flag 2 means what? That variable has coefficient and exponent terms available. Now let us see one example. So my example is 9x raised to 5 plus 7x raised to 4 into y plus 10xz. Now this is a polynomial containing multiple variables. Which are the variables? X, y, and z. And similarly, every variable has some coefficient and the exponent. Now let us see how to represent this particular polynomial with the help of generalized linked list. So very first node, we will write flag is equal to 0. Flag 0 means variable is available. So which is the variable in first term? X. So we are going to write down X. Flag 0 hai, so variable is available, and we have to have next pointer. In the next pointer, we have to write flag to 2. Flag 2 means what? Whatever variable just now you have introduced, what are the coefficient and exponent for that. So for that purpose, we have to set flag 2. Now flag 2 hai, so we have the coefficient 9 and exponent 5. So this first node and the temp node togetherly, they define the term 9x raised to 5. Okay. Now from the second term, you have the next pointer to the second term. Okay, from the second node, you have the next pointer connecting to the second term of the polynomial. Now in the second term, you can see 7x raised to 4y. Now x is available. For x already we have the declared a node, but what now the same node is there for x, same continuation is there. So what is the power of x over here? That is a 4, and we have to define 1. Why 1? Because down pointer is available. Down pointer available means what? There is not only x term, there is y term also, and for y term you need a separate node, so you have to have a down pointer. So we have to set flag is equal to 1. Flag 1 hai, that is the meaning that you have a another variable available, that is y. So you have to create that another variable y over here, okay, in the next hierarchy, and for that you have to give 0 as a flag. When flag is equal to 0 means variable is available, that is y, and there is a next pointer. Now what are the coefficient and exponent of y that we have to define in the next node? So you have to set the flag is equal to 2. Flag 2 means you have to set coefficient and exponent. What is the coefficient of the term? 7. And what is the coefficient of what is the power of y? 1. So 7 and 1, these are the coefficient and power of y, and then it is a last one. So you have to set next pointer to null. Okay. Now totally consider temp2 is attached to temp3, so it comes out to be 7y. Okay, and temp1 is attached to temp2, so it comes out to be x raised to 4. So the total temp1 into temp2 into temp3, it becomes 7x raised to 4 into y. Okay, your complete second term of the polynomial. And now come to the third term, that is 10xz. Now the first hierarchy is for x, so we have z over here, so we should have a down pointer, so we have to set flag to 1. Flag 1 means you have a down pointer, so let us create a down pointer. The down pointer will connect to a node of variable z, so flag is equal to 0 and new variable is z, and its next pointer, it should contain the coefficient and exponent for z. So 2 is a flag set. When flag is equal to 2, coefficient value 10, and what is the exponent of z? 1, and it's a last term, so next pointer will be null. Now it is attached to this node, so for this node, what is the power of x? Power of x is also 1, so you have to set 1 over here, and it is the last node for x also, so you have to set next is equal to null. So this complete 3 nodes, they represent the term 10xz, and this is how polynomials are represented with the help of GLL. The same explanation is given over here. Now what are the advantages? We talked about the advantages that the multivariable polynomials can be efficiently represented with the help of GLL. Although advantages are there, we have a disadvantage also. Disadvantage of using such node structure is different number of variables are required in different terms. So we don't know which type of polynomial we have to represent. Some polynomials may be having 2 variables, some polynomials might have 5 variables. So every time your variable, and that's why the number of nodes requirement will be different. Node size vary according to the number of variables. Yes, obviously, if you have 5 nodes, then 5 hierarchies you might have to develop. If you have more nodes, more hierarchies you need to develop, and that is why it makes storage management somewhat difficult. So this is all about the generalized linked list. Now let us talk about various applications of linked list in general. So a linked list is a very efficient data structure for sorted list that will go through many insertions and deletions. A linked list is a dynamic data structure in which the list can start with no nodes and then grow as new nodes are needed. A node can be easily deleted without moving other nodes, as would be the ease with an array. So for example, a linked list could be used to hold the records of students in a school. each quarter of semester, new students enroll in the school and some students leave or graduate, and you can efficiently manage these insertions and deletions with the help of data structure like linked list. So a linked list finally is a suitable structure if large number of insertions and deletions are needed, but searching and linked list is slower than searching an array. Okay, why? Because in array you can have direct access even to your positions, but in linked list you have to one by one node only you can search. Okay, this is all about various types of linked lists and their applications. Thank you.